This is another stellarium tutorial video. In this video, I'm going to show you how to find your location using the sun, so a type of celestial navigation. And I am here in stellarium. I'm on the ocean in a boat. Actually, there's no boat down here, but pretend I'm in a boat. And all I've got is the sun. There's the sun over there. And looking around the horizon, nothing else in the sky. So I wanted to do a celestial navigation problem. The problem that I gave you on problem set 2 had nice round numbers, and I decided I wanted to make this example a little more interesting. So instead of it being an equinox, it's February 10th, and I actually don't know where I am. I had a colleague set my location in stellarium to someplace I don't know, someplace in the ocean, and I am lost at sea and I need to figure out where I am. All I have is a clock, maybe a watch set to Greenwich Mean Time. So that's what I am showing right here, Greenwich Mean Time. And the way that I got that was to go to the configuration window. And one of the options is plugins. At the bottom, there's an option for time zone. And if I configure this, normally the default is that stellarium will use your system settings for standard time or daylight savings time. And I've said, no, just use universal coordinated time, which is essentially Greenwich Mean Time. So that's what we're going to use. The other thing that I did was I got rid of useful sky markings. So here I got rid of the meridian and the celestial equator and the cardinal points, and I changed my horizon to an ocean photograph just for photorealism here. I also have a sextant. So I have this in stellarium, I have this angular measure tool. I can bring it up by hitting Command A. And when I do that, I'm able to measure angles, like the angle of the sun to the horizon, like so. And so there's the altitude of the sun right now. And I also have a compass. So if I didn't have a compass, I wouldn't know if the sun is rising or setting. Let's say I'm really lost. I wouldn't necessarily know if the sun is rising or setting. It says in Greenwich, it's 10:23:58 in the evening, but I don't know if it's morning or evening here. That's going to affect, of course, my longitude. I could watch the sun over time and see if it gets higher or lower, and that would tell me if it's morning or evening. So it looks like it's gone up a little bit, even just in these few seconds. Let me let time pass a little faster. Aha, so you see the sun's rising there. And so that tells me that it must be morning here wherever I am. But I also am going to assume that I have a compass, so let me turn on the compass. So these are just azimuth headings, azimuth measurements all the way around the horizon. So there would be due north, and there would be due east at 90 degrees. And the azimuth of the sun right now is something like between 120 and 130, somewhere in there. Now, the technique that I'm going to use is very much an astronomer's technique. I'm going to use what I know about how the sun moves and latitude and longitude and the declination of the sun and so forth. If you were actually learning to do celestial navigation as a navigator going to sea, you would learn different techniques. I also am going to assume that I have a nautical almanac. So I'm going to actually just use the website for that. So I've got a table of the declination of the sun over the course of a year. This is averaged out for 4 years of a leap year cycle. So this could be a little wrong, up to 3/4 of a day wrong, just because of where you happen to be in the leap year. I could correct for that. There's a technique for correcting for that, but I'm not going to worry about that. I also have an equation of time, so that lets me convert from solar time to local mean time, and I'll need that to get my longitude. If you really were trying to learn to do celestial navigation, you would use a different technique. You would pick some object to sight, a star, the sun, the moon, and you would go through and basically follow a recipe in order to go through a series of calculations. You look up a bunch of things on a table, and you end up with a calculated latitude and longitude. There are classes you can take. There are online classes, tutorials, books that you can get. There's actually a website here at the Naval Observatory that will do the calculations for you. This is a technique where you have an assumed position and you make a measurement and then you do a small correction to where you think you are. So I'm not going to do any of that. I should also say, if you don't have a table of declination, given what you know about how the declination of the sun changes over the course of a year, you could probably do an interpolation. You know that it goes from negative 23.5 on December 21st to positive 23.5 on June 21st, and you could try and draw in a sine wave and come up with a reasonable guess for any day of the year what the declination of the sun is, to within a fraction of a degree, which may be accurate enough depending on what you're doing. All right, let's go back and figure out where we are. So first I'm going to figure out my latitude. And to do that, I want to look at the sun when it's local solar noon. I don't have to, but the calculation is much easier because I don't have to worry about the hour angle of the sun. The hour angle of the sun is 0 at local solar noon. Now, if I let time pass, I don't really want to just sit here and watch the sun. So I'm going to speed time up. There you see the clock going by. There's the sun getting higher and higher. If I didn't have a compass, I could of course use my sextant to find the sun when the sun reaches its highest point in the sky, and that would be local solar noon. Or I could use a shadow, and when the shadow is shortest, then it's highest in the sky. Now it's a little bit hard to see exactly when the sun's on the meridian, but I'm going to try and get as close as I can. So if I just go straight up from the 180 mark right there, a little bit later, I think it's right about there. It's a little tricky, but I think it's right about there. Maybe I'm only accurate probably within a couple of minutes. Now I see that I must be in the northern hemisphere because even though it's February and the sun's low, the sun's quite far from the zenith and it's south of the zenith. So if it were over in the northern sky, I would be in the southern hemisphere. But given that it's in the southern sky, I know that I must be in somewhere in the northern hemisphere. All right, let me measure the altitude of the sun. So I need my sextant. So there's my angle measure tool. And I go from the center of the sun down to the south horizon. And hopefully I'm not too far off. It says 40 degrees and 18 minutes. And I'm not going to worry about the seconds, the arc seconds. So 4018 is the altitude of the sun. So I'm going to write that down in my notebook. So 4018, 40 degrees and 18 minutes. I'm actually just going to go ahead and convert that to decimal degrees. So I add on 18 over 60, and there's my answer in fractions of a degree. And if I knew what the declination of the sun is, if I know what that is, then I can find out where the celestial equator is. It's February, so the sun must be south of the equator, so the equator is going to be somewhere north of the sun, and the angle from the sun to the equator is its declination. Now I care about where the equator is because that's going to tell me my latitude. So if I go to this diagram, the angle from the north celestial pole, where the star Polaris is, to the north horizon is your latitude. Now I know now I'm in the northern hemisphere, so I could wait until sunset and measure the angle from Polaris to the north horizon. And maybe I'll do that too. But it's noon and I can figure this out from the sun. The sun is going to take a path somewhere between these two solstice arcs. And since it's February, it's going to be somewhere here, kind of in between the solstice arc and the equinox arc. On Groundhog Day, it would take an arc sort of right about in between there, because it's about halfway in time from solstice to equinox. So it's going to take a path something like that across the sky. And at local solar noon, it's on the meridian, and so the angle from there to there is the declination of the sun, and then the angle from there to there is the altitude of the sun above the south horizon. The angle from the equator to the horizon is going to be 90 degrees minus my latitude. If this is my latitude, and this is 90 degrees from pole to the equator, then from here to the horizon must be 90 degrees minus my latitude. So where is the celestial equator? I need to add on the declination of the sun. I mean, really, it's subtracting, but I'm going to be subtracting a negative. So I'll take this number, the altitude of the sun, and subtract the declination of the sun, and it's going to be negative. So let's go look up the declination of the sun for February 11th. So I go to my table here. February 11th, it's at negative 14 degrees and 18 minutes. So let me write that down. So negative, we won't bring this up yet. So negative 14 degrees and 18, really it's 18? That's convenient. 18 minutes. All right, so as I said, I need to subtract this from this. So line 1 minus line 2. So 54.6 degrees, that's the angle up to the celestial equator. And so then 90 degrees minus that is 35.4 degrees. So that has to be equal to my latitude in degrees north. All right, we'll see how close I actually am. Now, to get my longitude, I need to know the local solar time. So local solar time is 12:00:00, I hope, because the sun is on the meridian. A sundial should read 12 o'clock. Local mean time, if I compare local mean time to Greenwich Mean Time, that'll tell me my longitude. So what is my local mean time? Well, I take local solar time and I correct it with the equation of time correction. So let's go look at the equation of timetable. Equation of timetable for February 11th. So it's a positive 14 1/3 minutes. So if it's positive, then that means the sun is slow. So that means that my local mean time should be a time which is actually bigger than 12. So I have to take 12 and add 14.3 minutes. So let's do that. So we'll take 12, and if I convert it to decimal hours, that's pretty easy. And I need to add on what's going to be 14.3. Okay. I've got to convert it to, I made a mistake there. I'm going to convert that to hours. There we go. So if that's in minutes and that's in hours, I have to convert to minutes of time. So local mean time is 12 hours and 20.24 hundredths of an hour. If I want to know what that is in minutes, I mean, you can see what it's going to be. It's going to be 12 hours and 14 minutes, but I can convert that if I take that 0.238 and multiply by 60, right, 14.3, so just like I expect. All right, Greenwich Mean Time at this moment is 02:35 and 23 seconds. I'm going to ignore the 23 seconds, so I'm going to say 02:35, and I need to convert that to decimal hours, so I'll take 02 plus 35 minutes, divide by 60 to get to hours. And so the difference between these two is going to be my longitude in hours. So I will take line 6 minus line 7, and I get 9.655 hours. Every hour of time that you change is going to be 15 degrees. So if I take that times 15 degrees, there's my longitude. Now, is that east or west? Well, it's noon for me when it's 2:35 a.m. for Greenwich. So that means I am east of Greenwich. So I think my latitude and longitude are 35.4 degrees north and 144.8. I should really round that off. Let's round that off to 144.8 degrees east longitude. All right, let's see if I'm right. I wonder where that is. I could go to my chart here, which is Google Maps, and I could say, all right, where is 35.4 north and 144.8 east? It's in the ocean. It's off the coast of Japan. Let's see if that's accurate. So I'm going to go to Stellarium, and I'm going to click here. And aha, I got plopped down at 36 degrees north and 144 degrees east. So that's not too bad. It's within a degree. Uh, Maybe it could have been a little more precise with my measurements, but it gives you the idea. Could have been a little bit more accurate, but not too bad. All right, that's my video. Hope that helps you understand celestial navigation.